Hello, welcome. Today we are learning about the areas of circles. Now, first thing we should look at is we need to remember the word circumference. So let's find the circumference of a circle with a radius of 4 centimeters. So if we have a radius of 4, we had two formulas for circumference. We could either say diameter times pi or 2 pi r, which r stands for radius. So we could, if the radius is 4, the whole diameter is 8, so we could say this is 8 pi, or or you could say it's 2 times pi times 4, which would also turn out to be 8 pi. Now if it says leave it in terms of pi, that means it wants a pi in our answer. Now our units on this one would just be centimeters. So what circumference means is if we start one point, let's start out here, and we measured the distance around the circle, that would be 8 times 3.14 centimeters around the circle. So 8 times 3 is 24, so we know it's a little bit more than 24. We could use our calculator to figure out exactly what it is. Now find the circumference of a circle if the radius is 7, if we wanted to round 2 decimals. So now we could do circumference equals diameter times pi. If the radius is 7, the diameter is 14. So 14 times pi is my answer. Now, if I put this into my calculator, 14 times 3.14, the circumference is 43.96 centimeters. All right, so now, if I have a circle made up of these pieces, I could take each of these pieces and pull them down here. And what I could create is something that looks something similar to a quadrilateral. We can try to put these into place. Alright, as I were putting this in place, I took some time and I just put them into place here on my next line. And so this here looks like a parallelogram, something similar to a parallelogram anyway, where it looks like so. Now it's not exactly a parallelogram, but it looks close. Now the distance from one base to the other is going to be the radius of the circle. The distance along one side here is going to be half the distance around the circle. We know circumference is 2 pi r. So half the distance around would just be pi r. So the distance from here to here is pi times the radius. And the distance from here to here is pretty much the radius. Now, if I wanted to find the area of this parallelogram, what I would do is take my base, which is pi r, multiply it by my height, which is r. So r times r would be r squared. So area would equal pi r squared. And this here is the formula for the area of a circle. Now, if we increased the number of pieces that we took out, here we took out 16 pieces, you can see that this looks even more like a parallelogram. So as the number of pieces increases, it gets closer and closer to a parallelogram, where the area is equal to pi r squared. Now if I want to find the area of this circle below, if the radius is 9, I just have to square that to get 81. So 81 pi centimeters squared is the area of that circle. Now in this case, if I want to find the area, first thing I need to do is find the radius. So if the whole diameter is 14, The radius is 7. So if I square that, I get 49 pi centimeters squared. Another one, if the whole diameter is 24, the radius would be 12. Now I have to square the radius to get 144 pi centimeters squared. Now in this case, we're going to find the area, but we're going to not have this in terms of pi. So what I want to do is take 5 squared, so that's 25 times pi. So now I type in my calculator 25 times 3.14, and I'll get 78.5. So this is about 78.5 centimeters squared. Now let's find the area of this. So this is going to be 1. 1 squared is 1. 1 times pi is 3.14. So 3.14 centimeters squared. So this is saying the unit circle, circle with a radius of 1, will have an area of 3.14. Now here we get a little bit trickier. It says find the area of a circle that has a circumference of 20 pi. So if the circumference is 20 pi, we know circumference is equal to diameter times pi, so that means 20 has to be the diameter. So if the 20 is the diameter, then our radius will be half of that, which is 10. So our area is going to be 10 squared, which is 100, times pi. Remember that's centimeters squared. Find the area of a circle that has a circumference of 8 pi. So take a second, pause the video, and see if you can do this one on your own. We have the circumference of 8 pi, so my diameter is 8, my radius is 4, so my area is going to be 16 pi centimeters squared. Find the circumference of a circle that has an area of 100 pi. So my area is 100 pi. So now if r squared, pi r squared is equal to 100 pi, if I divide pi on both sides, I'm left with r squared is equal to 100. Now if I take the square root of 100, r will be 10. So if my radius is 10, I have to find my diameter, which is twice that, which is 20, and multiply that times pi, and that's my circumference. And the units on that will just be centimeters. All right, now we get a little bit trickier. Let's find the shaded area here in red. Well, from the center to the outside is 13. So the area of the whole circle is going to be 13 squared pi, or 169 pi. So that's the area, I'll put a little c there, area of a circle. Let's find the area of the rectangle. Well, this point right up here is 512. So that means we went to the right 5 and up 12 to get to that point. So if I go to the right 5, and this is a rectangle, that would mean this distance here would be to the left 5. And if I go up 12, I would have to go down 12. So this entire rectangle is going to be 12 or 10 across the top, 24 down. So the whole area of the rectangle is going to be 10 times 24, which is 240. So the area of the rectangle is 240 units squared. So now I just have to subtract 169 pi minus 240. Now if I did that on my calculator, 169 times 3.14 would give us 530.66. Now I just subtract out 240 from that, and I get 290.66 square units. And that will be my shaded area here. Let's try this one. So we have one point here, and we know we want to find the red shaded area. we just have that one point right there. Now we know the radius of the circle is 5, so that's going to be 5 there and 5 out there. So the area of my circle will be 5 squared, which is 25 pi. Now, if I wanted to find this point here, it's 2.9 to the right and 4.3 down. That's saying that 4.3 is the apothem. So if I want to find the area of the pentagon, so what we would need to do is do 1/2 the perimeter times the apothem, or 1/2 side length times number of sides times apothem. Now if that's 2.9, this side over here is 2.9, so the side length is going to be 5.8. Now I'm going to multiply that side length times 5 to get 29. So the distance all the way around my perimeter is 29. So we're going to take half of 29 times our apothem, which is 4.3. That gets us to 62.35. So now to find the red area on the outside, I just have to take 25 pi, which is 78.5, and subtract from that 68.35. And so my area that's red, which we're looking for here, is 16.15. And I should say units squared. All right, here is our last problem of the section. Here we want to find the area and circumference of this object. So we're assuming this is all one big object. Say it's a track that people are running around, or I guess it's centimeters. Maybe a car is going around. Toy car, I mean. All right, so if I want to find the area, this here is a rectangle, so 20 times 10 is 200. This is half of a circle, a semicircle, and this is another half of the circle. So I can add these two together. This plus this will be pi r squared. If the diameter is 10, the radius is 5. So that plus that is going to be 25 pi. So if I add those together, I will get the area of that entire object. So that's 278.5. That's my area in square units, or square centimeters. Now my circumference I'm going to do in red. If this is 20, this distance is going to be 20. And now we have to do the distance around this outside plus this outside. And what you do is that creates a whole circle, which will be diameter times pi, or 10 pi. So we have 20 plus 10 times 3.14, which is 31.4. So if we add this up, we'll have 71.4 for our circumference. So 71.4 centimeters is the distance around this track. All right, hopefully that made sense to you. And now it's time to do the homework. Good luck.